We're going to be talking about absolute value. The thing to remember about absolute value is that it is the distance a number is from zero on a number line. A lot of times when people are dealing with absolute value in elementary schools, middle school, they get in the habit of just taking the positive of whatever's inside the absolute value sign. Well, that's true to some extent. It works on numbers like these, but when you get into solving equations, you always have to think about absolute value being the distance it is from zero on a number line. So if we have the absolute value of 7, again, the meaning of absolute value is it is the distance away from zero on a number line. So think to yourself, how far is 7 away from zero on a number line? It's 7 away from zero. So the absolute value, that's why it is 7. If you're looking at the absolute value of negative 5, think to yourself, how far is negative 5 away from 0 on a number line? It is 5 away from 0, so the absolute value of negative 5 is 5. And if you're looking at the absolute value of 0, that's not too tough. How far is 0 away from 0? 0 is 0 away from 0 on the number line. And finally, the absolute value of 1/2. How far is 1/2 away from 0 on a number line? Well, of course, it's 1/2. So the absolute value of 1/2 is 1/2. So yes, elementary, middle school, the habit of taking the positive of whatever's inside the absolute value sign, that does work. But when we get into solving equations, you do have to think about absolute value being the distance away from 0. If you're evaluating expressions with absolute value, you remember your order of operations. You work inside the parentheses or brackets, then you do the exponents, then multiply and divide from left to right, and then add and subtract from left to right. Well, these absolute value signs work the same way as parentheses or brackets. So you would want to do those first, work inside those, and then follow the order of operations. So for this one, it says evaluate 8.4 minus the absolute value of 2n plus 5 if the value of n is negative 7.5. So first thing we're going to do to evaluate this is substitute negative 7.5 in for n. So we're replacing the n with negative 7.5. Now again, we want to We want to evaluate or work inside the absolute value sign before we continue to follow the order of operations. So 2 times negative 7.5, that would be negative 15. And then work inside that, take negative 15 plus 5, that is negative 10. So it'd be 8.4 minus the absolute value of negative 10. Now again, absolute value is distance from 0. So how far is negative 10 away from 0? It's 10. So take 8.4 minus 10. And then finally, that would be negative 1.6. So when you substitute negative 7.5 into that expression for n, you evaluate that to be negative 1.6. Next, we're going to evaluate the negative of the absolute value of 3c minus a if a is negative 3 and c is 4.2. So to start this, we're going to substitute negative 3 in for a, and then 4.2 in for c as well. This would be the negative of the absolute value of 3 times 4.2 minus a negative 3. Watch your signs. A lot of negative signs involved here. We want to work inside the absolute value sign before we do anything else. And then once you're inside the absolute value sign, you are following the order of operations inside the absolute value sign. So take 3 times 4.2 inside the absolute value sign, it'd be 12.6. And then minus a negative 3, 2 negative signs back to back, that does make a positive. That would be a plus 3. So inside the absolute value sign, we have 12.6 plus 3. That would be 15.6. So we're looking at the negative of the absolute value of 15.6. Absolute value is distance from 0. 15.6 is 15.6 away from 0. We still have this negative sign out front, so that would be the negative of 15.6. No flies were harmed in the production of that last segment. Now on with the show. When you're dealing with absolute value, you always want to remember that absolute value is the distance away from 0. So if we're going to solve this equation, the absolute value of x equals 4, that's saying that the distance that x is from 0 is 4. Well, if you think about it, there are two numbers that are 4 away from 0. Think about the number line. You have a 0 in the middle, you have a 4 to the right, which is 4 away from 0, and you have a negative 4 to the left, which is also 4 away from 0. So the two numbers that are 4 away from 0 are 4 and negative 4. If you want to check that, put those back in. The absolute value of 4 is 4. And if you put negative 4 back in, the absolute value of negative 4 is also 4. So x does equal 4 or negative 4. Next equation, the absolute value of z minus 13 equals 21. That's saying that the distance z minus 13 is from 0 is 21. Think about it. What two numbers are 21 away from 0? Your number line was 0 in the middle. You got a 21 to the right, negative 21 to the left. So z minus 13 could be equal to 21, or z minus 13 could be equal to negative 21. So now we have two simple equations that we can solve for z. In this first equation, we're going to add 13 to both sides, and same thing for the second equation, add 13 to both sides. In that first equation, we get z equals 34. In the second equation, negative 21 plus 13 is negative 8. If you want to check those, put those back in. Put 34 back in for z. It'd be the absolute value of 34 minus 13. That's the absolute value of 21. That is 21. And if you put negative 8 back in, the absolute value of negative 8 minus 13, that'd be the absolute value of negative 21, and that is 21. So z does equal 34 and also negative 8. Next equation is 9 equals the absolute value of d plus 5. Now, it doesn't matter which side of the equation or the equal sign the absolute value is on. That makes no difference. Usually it's on the left, but this one happens to be on the right. It doesn't matter. So if 9 equals the absolute value of d plus 5, that's saying that the distance d plus 5 is from 0 is 9. Well, there are two numbers that are 9 away from 0 on a number line, 9 and also negative 9. So the value of d plus 5 could be equal to 9, or it could be equal to negative 9. Once we set that up, we have two simple equations we can solve for d. In that first equation, subtract 5 from each side to get d equals 4. And the second equation, same thing, subtract 5 from each side, d equals negative 14. If you want to check your answers, put those back in. Put 4 back in for d. It'd be the absolute value of 4 plus 5. That's the absolute value of 9, which does equal 9. And put negative 14 back in, the absolute value of negative 14 plus 5. That'd be the absolute value of negative 9, which again is 9. So d does equal 4 and also negative 14. Those work. Next equation, 5 times the absolute value of x plus 6 equals 20. Now we do have a 5 in front of the absolute value sign. One way to think about that is think of that absolute value as another variable. If it was 5 times y equals 20, you would divide each side by 5. Well, that's what we're going to do here, is divide each side by 5. When you're solving these absolute value equations, you want to isolate the absolute value and get everything else to the other side. Just like you would a variable. You want to isolate the y here by getting the 5 to the other side. You want to isolate this absolute value by moving the 5. And to do that, you have to divide each side by 5. So we have the absolute value of x plus 6 equals 4. That's saying the distance that x plus 6 is from 0 is 4. There are two numbers that are 4 away from 0. Again, think about your number line with 0 in the middle. You have a 4 to the right, negative 4 to the left. Those are the two numbers that are 4 away from 0, and those are the two numbers that x plus 6 could be equal to here. So x plus 6 could be equal to 4, or x plus 6 could be equal to negative 4. In each equation, we're going to subtract 6 from each side. In that first equation, 4 minus 6 is negative 2. In the second equation, negative 4 minus 6 is negative 10. So x does equal negative 2 or negative 10. To check those, put those back in, and you're going to find out x does equal negative 2 or negative 10. Here we have 3 times the absolute value of 2a minus 4 is equal to 0. So that 3 out in front of the absolute value sign, that needs to be moved to the right side. We need to isolate the absolute value, get everything else to the other side. So to move that 3 to the other side, we would divide each side by 3. We end up with the absolute value of 2a minus 4 is equal to 0. Now that's saying the distance that 2a minus 4 is away from 0 is 0. Well, there's only one number that's 0 away from 0, and that number just happens to be 0. So if the distance that 2a minus 4 is away from 0 is 0, then 2a minus 4 would definitely be equal to 0. To solve that equation for a, add 4 to both sides. We have 2a equals 4. and then divide each side by 2, you do end up with a equals 2. Now you can check that, put 2 back in for a. When you put 2 back in for a, you're going to get a true statement. Both sides are going to equal each other. You're going to get 0 equals 0 when you substitute 2 back in for a. That tells you you are correct. A does equal 2. Next equation, 3 times the absolute value of 2y minus 3 minus 5 equals 4. We have 2 things we have to move here. We have to move this negative 5 to the right side. We also have to move this 3 to the right side in order to get the absolute value by itself. If that absolute value was a z, it'd be 3z minus 5 equals 4. You'd move the 5 first, and then you'd move the 3. So to move that 5 to the other side, we're going to add 5 to both sides. And if you do that, get 3 times the absolute value of 2y minus 3 is equal to 9. Now to move that 3 to the other side, divide each side by 3. End up with the absolute value of 2y minus 3 is equal to 3. Now that's saying the distance that 2y minus 3 is from 0 is 3. There are 2 numbers that are 3 away from 0. You have a negative 3 on the left side of 0, and you have a positive 3 on the right side of 0. So 2y minus 3 could be equal to 3 or negative 3. Those are the 2 numbers that are 3 away from 0. Now we have 2 simple equations that we can solve for y. In each one, we're going to add 3 to each side. In that first equation, get 2y equals 6. In the second equation, 2y equals 0. Continue solving for y, divide each side of each equation by 2, and we do end up with y equals 3 or y equals 0. So that's saying the value of y in this equation is 3, and it's also 0. You can check those, put those back in, put 3 back in for y, 0 back in for y. You will get a true statement where both sides equal each other. You would get 4 equals 4 when you put both of those back in. Y equals 3 and y equals 0.